Computers are wonderful machines that can help us do a lot, but they're even more helpful if we can harness the power of multiple computers. Networks do that. This talk will go over types of networks, how they work, and how all this relates to the internet. Networks are simply two or more devices communicating with each other somehow, whether that be wirelessly or through a physical connection using an Ethernet, coaxial, or fiber optic cable. You may hear terms describing types of networks. A personal area network is usually something created in your immediate vicinity, like having your Bluetooth headphones connected to your tablet, which is wirelessly connected to a printer. A local area network extends that range a bit and can include computers and smart TVs in your house, or classroom computers in a building, or buildings on a campus. A metropolitan area network extends that range and can include buildings in a city or spread out across several small neighboring towns. A wide area network extends that to include campuses that might be in different locations, maybe something connecting business locations on both coasts of the US, for example. Most of the time you'll see LANs and WANs, but just be aware that there are other types of networks, including some that aren't listed here. Networks can also be classified by who's in control of data flow. In a client-server network, client or workstation computers connect to servers for access to things like emails, printers, or storage. You'll see that most often in businesses and schools. In a peer-to-peer network, all devices are on equal terms. Your home networks are more than likely in a peer-to-peer configuration. If you remember back in the day when we had things like Kazaa or LimeWire to share files, those were essentially peer-to-peer networks. There wasn't a centralized storage location for all the files that were traded. Everything was spread out on everyone else's computer. Compare that to Napster, where everything flowed in and out of Napster's servers. This is why the government was able to shut down Napster. They knew where all the illegally traded files were located and could shut that server down. For Kazaa and LimeWire, on the other hand, there was no central location, so shutting that down was a lot more difficult. So far, we have types of networks based on location and types of networks based on control. These are types of networks based on how data flows. In a bus network, computers work on a single shared wired communications medium. These are easy to set up but can't handle large numbers of devices because there's nothing controlling the data flow. An analogy would be having people in a meeting. If your meeting had 10 people in it and two people started talking at once, you'd have to stop and figure out who wants to talk first and then start over. Imagine having a meeting with 20, 50, or 100 people. You'll never get anything done. That's essentially how a bus network operates. Anyone can use the network whenever they want, but if two devices try to at the same time, data would be lost. A bus network usually caps out at 10 devices anymore, and you'll end up in a shouting match with the other people in your meeting. A ring network attempts to control that meeting by allowing only the person with the ball, stick, or something else to speak. Once that person is done, that ball would be passed to the next person to speak. A ring network works the same. Sometimes you'll hear this called a token ring network, and the token is passed from computer to computer to allow them to communicate. This is great because of the control element, but it's tough to expand a token ring network, and if you go beyond 100 devices, network communication gets slower since that token has longer to travel. A star network connects devices to a central point like a hub or switch. These are easy to expand and are the most popular ones you'll see in the real world. Most of your home networks are in a star configuration. Your household might look something like this. You might have a smart TV, some wireless devices like laptops and phones, and possibly a wired computer, all connected to a wireless router, which is then connected to some kind of a modem that you got from your internet service provider. Earlier, we talked about star networks having some kind of central point of connection. That point of connection is usually either a hub or a switch. They look the same if you put them side by side, but hubs repeat everything to everyone, while switches momentarily make connections between two devices and allows for communication only between those two. Chances are you'll never see a hub in action, but just be aware that they exist. Routers are devices that connect different networks together. Your home network is its own private collection of devices, and the internet is its own collection of other devices. Routers bridge the gap between the two. Your wireless router is more than likely a switch and router combination. There are usually a few ports in the back of your wireless router that you can connect printers, desktops, laptops, and gaming consoles to. That's the switch part of the device. It allows that connection of devices in a local area network. Then there's a port that connects your wireless router to your modem, and your modem connects to the internet. That port on your wireless router is the router part of that device. Your home network is its own network, and the internet is a bunch of other different networks that you're trying to connect to. Sometimes you don't have two separate devices. Sometimes your internet service provider will give you a single box that has switch, wireless, and router capabilities. If that's the case, you're probably renting that device from your ISP. If you didn't know, you can probably buy a cable modem elsewhere and install it yourself and save yourself that monthly charge. Check with your ISP to see if they have a list of cable modems that work with their network. If you have your own separate wireless router, or if you're using your ISP's device, be sure that you take some precautions. For one, accessing the settings should be secured. Most of the time, if you buy a wireless router, the login and password are something easy like admin and password. Be sure to change that password to something strong. If anyone were to pull up into your driveway and get access to your wireless router, you could see a lot of weird things going on with your home network, so make it more difficult by changing that password. In addition to that, be sure to enable wireless encryption to protect the broadcast part of your network. Stay away from WEP if you see that's easily hacked. Stick with WPA3 or the highest number WPA that's available on your device. You might also want to hide your SSID just so no one will know you're broadcasting. And you might also want to restrict the devices that are allowed on your network. Both security options can be found in your device's settings. You may have to look up where exactly you should go to configure these, since devices will have different interfaces. All devices on a network need some kind of identifier. That's where IP addresses come in. IP stands for Internet Protocol and is how devices are identified. IP addresses must be unique. What's listed here are IP version 4 addresses, which is the older but still widely used version of IP addressing. There are 4 numbers in an IPv4 address, and each number can be between 0 and 255. The latest version is IPv6, where the addresses are much longer and are a mix of letters and numbers instead of just numbers. Technically, IPv4 is a string of binary numbers that are converted to decimals so we can understand them easier, and IPv6 uses hexadecimal numbers. When you go outside of your household, every other site you connect to also has an IP address. Remember that the internet is the physical connections between computers. It's a giant network made up of a bunch of other networks. It's a network of networks. Since they're networks, websites also need IP addresses so that people can communicate with them. Your ISP's modem is the device that connects your home network to the rest of the world, and that will have its own IP address just the same. Everything in your household is essentially hidden from the rest of the world by that modem. That modem is your public IP address, and all traffic goes to that. When you're paying your ISP for internet service, they guarantee that you have a certain level of speed so that all those Netflix movies you're watching will play smoothly, and the Spotify playlists you have in your home office are not skipping around. It's not a bad idea to see how fast your internet speeds actually are. There are a few sites out there that will measure that for you. Check out speedtest.net and see if you're actually getting what you paid for. Generally speaking, if you're just using the internet for everyday surfing, 100 megabits per second is good enough. But if there's a lot of online activity, whether you're gaming or streaming or downloading files, higher is better. Look for 500 megabits or faster if that's the case. We mentioned public IP addresses earlier. Public IP addresses are known addresses. That makes sense when you think about it. If you're trying to get to Amazon, your computer needs to know what Amazon's IP address is to make that connection. Devices in your household use private IP addresses, which the outside world doesn't know about. Devices in your household still need a way to talk to each other, but the outside world doesn't know that. The outside world communicates through the router part of your modem. It's almost like having a PO box. If you get mail from someone, that person doesn't necessarily know what your physical address is, but they know that if they send mail to the post office, it'll eventually get to you. That's what your modem does. Every time you do anything online, that goes in and out of your modem. Your specific device is hidden from the rest of the world. Amazon may know that your household is shopping around, but Amazon doesn't know if you're doing it on your laptop or desktop. Private IP addresses start with 10, 169, 172, or 192. Again, no one in the outside world sees private IP addresses. This is why if you look at your wireless router's IP address, it's probably 192.168.1.1. A lot of routers will come with this IP address set by default. Earlier we said that all devices must have a unique IP address to communicate. This is true in a private network. All your devices in your household must have different IP addresses. But since it's private, your neighbor's home network doesn't know that your desktop is using 192.168.1.67, so your neighbor can use that too for a gaming console. Your neighbor's wireless router can also use 192.168.1.1. But your neighbor's modem's IP address will be different from yours because that's a public IP address, and that's how Netflix knows to send Stranger Things to you and Squid Game to your neighbor. Your modem then figures out what specific device is watching those shows, and voila, you're binging on your iPad. If you're curious as to what your IP address is, you can use the command prompt in Windows to tell your device's IP address as well as your wireless router's IP address. That will usually be listed as your default gateway. If you want to know what your public IP address is, visit whatismyipaddress.com. You normally won't need to know what your IP addresses are since that all happens behind the scenes, and for the most part, you don't need to configure anything. But if there's ever a problem with your network or your internet connection, knowing what your IP addresses are might help with troubleshooting. Remember that the internet is a network of networks, and those networks are connected to each other through routers and cables. When anyone says the cloud, that could mean any number of things that are internet related. When you see the internet drawn symbolically, it's usually represented by a cloud to represent the different routers and cables and the pathways to connect everything to everything else. It's much easier to draw a cloud than to draw each router. So when you hear about cloud computing, that simply refers to computing through the internet. You're using someone else's computers to do things for you, like run programs or mine cryptocurrency. Cloud storage is similar. That's storing files on someone else's computers using the internet to connect to them. Let's talk about privacy. As we've mentioned before, your modem has a public IP address attached to it. Whenever you connect to a website, your location is known to that site. If you've ever heard of people trying to watch something online or access a site online and they get blocked because they're not in the area, this is why. IP addresses are publicly known, and if a site didn't want you to see something because you're from America or France, they could block traffic from any IP address known to be in either of those countries. If you want to protect your location, you could use a virtual private network or VPN. Remember that a private network hides individual devices from the internet, like your household. A VPN does the same thing. It can hide your modem's public IP address behind that VPN's network. If you wanted to watch something on Netflix and you use a VPN, the communication goes from you to the VPN and then to Netflix. You and the VPN are now a household of sorts, so all Netflix sees is your VPN's public IP address, and all traffic is routed there. Then your VPN routes traffic to your modem, and then that routes it to your device. Other than the VPN, no one knows where you are. They all think you're wherever the VPN is, so your location is hidden from the world. This is also how some people get around those sites that lock you out because of where you are. All you need to do is connect to a VPN that's in an acceptable region and then go to that site. That site will think that you're wherever your VPN is and send you content accordingly. Aside from playing hide and seek with everyone on the internet, a VPN can also be helpful if you're working remotely. If a company has a VPN set up on their server, and if you have a VPN application that connects to that server, then it doesn't matter where you are physically. Because of the VPN connection, that server will think you're on the premises, and you'll be able to do things like connect to a company's shared drive or printer as if you're really there. Let's close by talking about who owns the internet. Does any one entity own or control the internet? The short answer, no. We've already discussed that an ISP gives you a way onto the internet through a modem. There are lots of ISPs out there, each with their own fiber optic cables and routers helping to connect everyone. It's a shared responsibility. Everyone more or less watches over the internet, provides some guidance as to how things should be developed through different organizations, and gives people and businesses access. In some cases, the government owns and maintains all the routers and connections, like in China or North Korea. In those cases, the government can control what's being let in from other countries and what their citizens can see. Remember that IP addresses are public, so it's easy to block international data. But aside from these two countries, the internet is generally available to everyone. The argument behind net neutrality has simmered down a little bit, but it's important to know what that was all about because it has the potential to affect how much we're paying to go online. Net neutrality is basically the idea that all network traffic should be treated the same. It shouldn't matter that Netflix and Hulu are sending more data on the internet than Etsy and eBay. It doesn't matter who's sending what data or how much they send. There shouldn't be any restrictions on that. People that want to see a fair and balanced internet say that if ISPs get to control internet traffic, costs could potentially rise for everyone. Smaller content providers may not be able to have the same reach as larger ones like Netflix and Hulu. Plus, if ISPs are allowed to control pricing more, they could charge the larger content providers more, which would trickle down to their users. Since ISPs have a stake in the internet, their claim is that if content providers use the internet more, ISPs should be able to charge them more to cover maintenance and other costs. It's almost like a toll road. If Walmart is going to use a road more to deliver their goods, then they're going to pay more in tolls to cover the fact that their trucks are wearing the roads down more than everyone else. ISPs also argue that they should be allowed to prioritize traffic. If you've ever seen areas that use a FastPass kind of a system where drivers can pay to get on a less congested road, that's the same idea that ISPs want to implement. If folks like Netflix want to guarantee that their data gets to their customers, ISPs want the ability to charge them more for that privilege. The argument came down to how the internet is perceived. If the internet, or broadband, were to be classified as a communications medium, then it'd fall under a different set of rules that would give ISPs more control over pricing. But if broadband were to be classified as a utility, then that would mean there would be stricter controls, much like electricity and water companies. This made sense to a lot of people. Just about everything we do requires the internet. Yes, it is a communications medium, but it's also something pretty essential to everyday life, like electricity or water. In the end, it was ruled that the FCC didn't have the authority to reclassify broadband communications, so control went to the ISPs. So far, ISPs and content providers have been pretty level with their pricing, but time will tell if they can continue to keep things affordable for everyone or if things get out of control.